So I think I can start and people can join in the middle. Okay. So if you have any question or any doubts, and if you have any problem in whatsoever I'm telling you, uh, in any kind of understanding, then you can just ask me in the middle also. And I want you to interact also. Like it will be tough for me if I will just talk to myself. Okay. So I'm Kamna Mishra from IIT Mandi, and I'm here for your like live session, and I will try so that I will try you to teach, and maybe so that you will understand the things probability and statistics, and I will give some examples, and before that we will do some revision kind of thing. So I'm firstly sharing my screen. Just screen. Yeah, so my screen is visible to you, right? Okay. So actually, I'll not be able to see the messages all the time, so I just want you to tell me if you have any issue. And okay, let's just start. So this is week 1, and I have already introduced myself. I'm Kamna Mishra, and this work is going on by the instructor, Professor Samesh Kumar from IIT Kharagpur. So the first page I have just given here is for the revision. Uh, okay. So now, can you tell me what is the probability of empty set? Like this probability of empty set, what will be? Anybody please answer? Hello? Hello? Yeah, it's it. Okay. So probability of like if we have a sample space, then it's if the total sample space probability is 1. So these are some basic things you need to know, and there are some basic formulae like probability of A union B. What is probability of A union B in terms of probability of A? So if you know all these things, then we can skip. So do you know all these things, or you have any kind of issues in these things, like what is mutually exclusive event, what is mutually exhaustive event and all? So, uh, can you repeat what you have said? Okay, you don't have such kind of queries. Okay, so you know all these things, right? Probably what is mutually exclusive, mutually exhaustive events, and independent and all. Okay, so then we can start by solving the problems. Okay, so we have this first question. This is, I think, very simple question. So, what is prime number? What is prime number? Like, you don't need to give any definition exactly, but exactly, yeah, 235. Like, yeah, it is either divisible by 1 or it is divisible by itself. So, for x is the set, like we have the set x is equal to x such that x is is equal to 2n minus 1, where n belongs to natural number and n less than 3. So natural number starts from 1, 2 and 3. So we have 1, 2 and n is less than 3, so we will not take that. So for 1 it will be 2 into 1 minus 1, and for 2 it will be 2 into 2 minus 1. So ultimately we have 1 and 3. Now similarly we can find y. So y will be 2, 3 and 5. If we now take intersection of it, it will be 3. So I think this will be clear. It's kind of very easy question. Now we have a question is that let A be the set containing numbers from 1 to 100 which are not divisible by 2, 3 and 5, and then we want to find the cardinality. Do you know what is cardinality? What is cardinality? Number of elements in the set. Okay. So anybody can tell me how we can approach this problem? Okay. So what we will do is that sorry, E we have a set, and it contains the number between 1 to 100 and which are not divisible by 2, 3 and 5. So firstly we will want to find what are the numbers divisible by 2, 3 and 5, and then its intersection, like pairwise intersection, and then uh, intersection which will be divided by 2, 3 and 5. So now let's say A be the set where the numbers we have the numbers which are divisible by 2. So in 1 to 100, how many numbers we will have which will be divisible by 2? Like n a, or cardinality of A also we can write. If we have A is any set where which contains the number which are divisible by 2, then what will be n a? Yeah, it will be 50. Okay. Now simply similarly what we will take B as the number which are divisible by 3. Now we want to find what is NB. And it will be 30. Okay, I'm so sorry for this inconvenience. And B will be cardinality of B. Is there anybody know how to solve this problem? I don't know what's happening. Okay, NB, will it be 30 or more than that? Huh? Means it's not 30 actually. So do you want to do any second guess, or you want to solve it again? Hello. Yeah, I think there are enough number of participants who can answer it. So please try to interact. Okay, so if I will tell you the simple trick, if you just want to know that what are the numbers, like if you have 100 numbers, 1 to 100, and which are divisible by 2, 3, 5, or any numbers you have, then just divide that number. Like if I have 100, and I want to find how many numbers we have which will be divisible by 3, then just divide it by 3 and it will be 33 point something, then its cardinality will be 33. How? If we have like 1 to 100 numbers, then the first number which will be divisible by 3 will be 3, and then 6, and then 9. So ultimately, if we divide it by 100, like if we have 1000 number, 1 to 1000, and we want to find which are the numbers divisible by 3, then we can simply divide 1000 by 3 and take its like the number which is before the decimal point. So it will be 33. Okay. So now C will be the numbers which are divisible by 5. I think there is some issue in my pen. Okay. So what will be the cardinality of C? 20, right? Okay. So okay. Now we have the numbers which are divisible by 2, 3, and 5. Now basically what the formula we are using here is that n a intersection b intersection c is equal to n a plus n b. You must have heard this. Okay, so we want to find n a intersection b intersection c. So these are the number which are divisible by 100 and its complement, which are not divisible by 2, 3. So now we want to find n. We have NA as 50, NB as 33, and NC as 20. Now we want to find what is NA intersection B. Means the numbers which are divisible by 2 and 3. So how we can find it? Yeah. Yeah. So if we have 2, 3, then we will take LCM of 2 and 3. If we have 2 or 4, then we will take LCM of 2 or 4, then it will be 6. Like 4. Sorry. So now we have the LCM is 6. So its cardinality will be 100 divided by 6. What what is the answer of this? 100 by 6 almost 60. Okay. So similarly we can find B intersection C. It will be 4. Okay, 3 and 5 will be 15, right? So 100 by 15, it will be, I think, 15 times 6. Yeah, 6. 6. And C intersection A will be 2 and 5. So 2 and 5, I think 10. So 10 by 100, 10. Right? Okay. So we have A, B, C, A intersection B, B intersection C, C intersection A. Now the last we have A, B, C intersection. So it will be 2, 3, and 5. Can you just find it? An A intersection B intersection C. It will be 2, 3, and 5. So 5, 10, 30. So 30, 100 by 30, it will be 3. Right? So we want to find, oh sorry, actually it's union. So we have A union B, and A union B union C will be 50 plus 33. Okay, let me write it here. A union B union C, it is NA plus NB plus NC minus N of A intersection B minus N of B intersection C minus N of C intersection A plus N of A intersection B intersection C. Okay, so what was NA? It was, I think, 50, right? It will be 50 plus 33 minus, sorry, plus 20 minus 16 minus 10 minus 6 plus 3. So what it is, can you calculate? Can someone please calculate it? Yeah. Yeah, you can discuss it once your due date is over. Like what, I cannot discuss it. Like if you have any doubts, I can try. But like since you have a due date, then after that, if you have any issue, you can ask me. And if you have any issue in like lectures, then you can ask me. But right now, I can't solve the assignments you have. Hmm. Hmm. Okay, after solving this problem, can you just share the screen where you have problem, okay? Okay, so what's his answer? 74. Okay, so the final one we wanted to find was that N A union B union C complement. So it will be 100 minus 74, and so answer will be 26. So here it was the answer, and here this is the answer. Yeah, okay, so I will stop sharing and you can share your screen. Yeah, yeah, sure. Uh, yeah, okay. X omega is less than equal to lambda. Yeah, actually, is somebody else telling something else? Anand, your voice is not clear. No, it's not clear. You can write, or you may either disconnect your earphone or whatsoever you are using. Yeah. I know I'm actually unable to understand you. So Anand, you can write. Actually, I cannot understand whatsoever you are saying. It's just totally breaking, nothing else. Okay. Okay, so actually, when we generally talk about probability, what we do is that we start with a random variable. We say that this is a variable, and then randomness comes under when we select it randomly, right? But this is a typical form of defining random variable. What it means is that we have a probability space, and then we try to define a function. Okay, so a random variable is nothing but a function. If we have any set and then we define it as a function, like if we have a set x is equal to head, 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 tail, tail, head, and then so what we do is that we try to define it as a random variable. We take head, head as like head is zero and then one, like 0 1 2. So probability of getting 0 head, 1 head, 2 head. So what we say is that this is the random variable. But this is kind of a theorem. You may not use it anywhere. It may happen that you will not use it anywhere, but these are the condition that will satisfy, you know. But in terms of lambda, why it is written, I need to understand. So I need just 2 3 minutes. I'll tell you later. Okay. So x is defined on sigma, and b has a, so b is, I think it's measurable space as far as I know, and let sigma be those class of subsets of R, so that is be a sigma field. So if x is defined on this, okay, is a random variable if and only if any one of the following condition is satisfied. So omega is x omega, x of omega is less than lambda, lambda tends to omega, x omega is lambda plus lambda tends to, and then x omega. Okay, I have an example. I have written that before. I think sir has told you also. So, yeah, just a minute. You can ask next out too. So what it means is that I think if you have like B will be your set. So it is given that W or omega whatever x omega less than or equal to lambda belongs to this for all lambda belongs to R. Okay. So as far as I know, if sir has given one example is that x we have like number of heads, let's just say, okay, and mm, so the sample space we will have will be h and t. So omega x omega less than equal to lambda will be the space we want to find now this space. So when lambda is less than 0, when lambda is less than 0, 0 1 2, so when lambda is less than 0 it will be an empty set. When lambda will be greater than this and this, like if we want to find the number of heads when lambda is in between 0 to 1, it will be it will be h I think, and when lambda will be greater than this, yeah, okay, okay, I think you are presenting, that's what the issue. Okay. Are you still presenting? Okay. So, okay. So what I was trying to tell you is that you have the question is that what is this condition means basically, right? So we like for lambda belongs to R, like if lambda is equal to 0 1 or any real number like lambda is 0 0 to 1 or a lambda greater than 1. So I think in the slides you must have find in the lecture, sorry, you must have find this examples that is given. So by that I can try. So you have H and P. So basically this B will be your phi T H and H and T. Okay. So if you try to find this omega less than or equal to lambda, so it will be when lambda is less than 0, it will be empty set. When lambda is in between 0 to 1, it will be just t. And when lambda greater than equal to 1, it will be h and t. Okay. So now these all belongs to P. So what we can say is that this is a random variable. Now this x is a random variable. But if x is something which is not defining this property, like uh, let's say x is 0 1 2, uh, then we cannot define it I think here, because if we have just head and tail are the things, then we cannot define two tail like h h t t. If we have just h and t, then we cannot define random variable as 0 1 2. We can define as z 0 or 1. So this may be the problem. This will be probably, probably this will be the thing, but I will try to explain it like in a better way in the next class. I will just read it again. Okay, and if you have any other doubt, you can ask. Huh. Oh, okay. Yes. Yeah, yeah, you can present. I will just stop presenting. Yeah, you have. Okay, I have already taken a similar question in this, like whatsoever slides I'm taking. So you will understand it later. Okay. Okay. So you can start presenting. I'll present this. Okay. So we did up to here. Now, so here, this is also, I think, a simple question. P is an odd. P is the set where P is odd prime number. So we have 3, 4, 5, and 7. Uh, so do you know what are proper subsets and improper subsets? Okay. So if like A is pro A, this is we said A is subset of B. So A is proper subset of B if A not equal to B. Okay. So I think this is very clear. So if we have like P is 3, 4, 5, 7, then P itself is not its proper subset. P is improper subset. And all the other subsets are proper subsets. So the number of subsets, number of subsets, basically what is it says like power set, number of subsets. Do you know what is its value? If we have any set which is whose cardinality is n, then what is number of subsets it will have? Yeah, yeah, 2 raised to power n. So number of proper subsets we want to find here. So it will be 2 to the power n minus 1. Okay. So in the first we have 4. So it will be 2 to the power no, 3. So sorry, 357. This is not prime number. 357. So it will be 2 to the power 3 minus 1, which will be 5. Sorry, 7. Now, second, we have Q. Q is that B such that B belongs to natural number 0, B up to n. So B will Q will we will have as 1, 2 up to 8. Okay. So the number of proper subsets it will have will be 2 to the power 8 minus 1. So 2 to the power 8 is 256, I think. So it will be 255. So this will be the answer. Do you have any doubt? Okay. So let's just move to next question. Okay. Now we have the question is probability of A intersection B is this, A intersection B complement and this. Okay. So whenever you have any question like this, so the best way to solve is using Venn diagram. So what we will do is that we will make Venn diagram here. Okay. So what is given here is that probability of A intersection B is zero point 0.4. What is A intersection B complement? So this region will be B complement and intersection A will be this. Now let's just see what is this region. We have A, B. So A complement will be this region, and B complement will be this region. Okay, so its intersection will be this region outside portion. So this portion, it will have the probability 0.3. This one is zero point 0.2. Now we want to find the probability of B. So what will be the probability of B from here? Like if we use Venn diagram, what we do firstly, the total probability will be 1, which will be sample space. So total probability will be 1. So if we remove this zero point 0.3, we will have this portion only, and then if we remove this part also, then we will have the portion probability of B. So what we will do, it will be 1 minus zero point 0.3 minus zero point 0.2. So the answer will be zero point 0.5, right? Now the probability of A given B will be probability of A intersection B divided by probability of B. So A intersection B, we have here zero point 0.4, and this is zero point 0.5. So it will be zero point 0.4 by zero point 0.5. So the answer will be zero point 0.8. So zero point 0.5 and zero point 0.8, this will be the answer. Now, this is a question like we have a different like fruits, apples, mangoes, and guavas, and then we just want to find the probability. Now, you need to firstly understand what is the difference between without replacement, with replacement, and randomly taking just uh, picking or just taking the fruits. Okay, so if you have given that fruits are like selected one by one without randomly one by one without replacement, then it means that we have a basket and then we are taking one, and then from the remaining we are taking now second, and then third, and then fourth. But if you say that we are taking randomly four, so you will just randomly pick four one at a once, like not one at a time, but all the fours you will take at once. And if you have with replacement, then you will take firstly you will pick one fruit, and then you put it back, and then you again choose. So what changes it will give to probability is that uh, if we say we want to select one by one, so firstly we have 7 apples, okay, 5 mangoes, and 10 guavas. So total number will be at 10, 7, this one will be 22, right? So if I say I'm picking 4 fruits randomly, then it will be 22C4. If I will say randomly, it will be 22C4. If I will say that I'm picking it random without replacement, it will be 22C1, 21C1, 20C1, and then 19C1. Okay, and if I will say that I will pick it with replacement, then it will be 22C1 to the power 4. You have understood it, right? Everybody? Yeah. Yeah. Uh, yes, yes. Yeah, no, I'm just telling you, like what we do in the probability that first fruit is mango, then we will take 5 by 24, right? So we are picking any, uh, like we will pick for the first one fruit, and then we want to find the probability whether it is mango, okay? Then it will be 5 by 22. I'm just telling you that how you will write this, the denominator part. So if you have four fruits you are selecting, you are just let's say you have a basket and you have different kind of fruits, and you just want to select four fruits or three fruits whatsoever. Then if if the question is written there that we are selecting it randomly, then you are picking all the fruits, all the number of fruits which is given, like four or three, you will pick it one at once. So it will be 22C4. If it is written that random one by one without replacement, then it will be random without replacement will be 22C1, 21C1. What we are doing is that firstly we pick one fruit, okay? So we have 22 fruits and we are picking one, and then we are checking whether it is mango. So the probability will be 5 by 22. Now we have left with 21 fruits, okay? In total we have 21 fruits, and then we want to find whether the second one is guava. So guava we have 10, so it will be 10 by 21, not 10 by 22. Okay, now is it understood? So now we will solve this question, because with here it is written we are selecting randomly one by one without replacement. So first is we okay. First is that what is the probability that first fruit is mango. So mango it will be by 5 by 22. Okay. For the second one we left with the 21 because it is without replacement. So it will be, and we want to select the guava, so it will be 10 by 21. Okay. Third is apple. So apple will be 7 and then 20, and then fourth one is mango. So now we don't have that mango, we have already taken it out. So we have left with four mangoes. So it will be 4 by 19. So this is the answer. Now you can just solve it and it will, I don't know what's the answer. So you can just solve it. I think it will be 5, 4, 20, and then 7, 3. It will be 5, 11. So it will come like 5, 11 times 3, 19. So now you can solve it, I think. So it will be something, maybe this is the answer, 5 by 6, 27. Okay. Any doubts? Yeah. Why we are not okay? Why that's why I told you that why we are not using 22C4, because the question in the question it is written that we are randomly picking one by one without replacement. We use 22C4 when we select all four. Like if you have 10 balls and you have selected four, and then you have just selected four, okay? You are not picking one and then second and then third and then fourth. So what it means is that when we use 22 into 21 into 20 into 19, so 21 means well, we have picked one out of 22, then second, and then third, and then fourth. That is why it is written one by one without replacement. But you when you select randomly, that means you are selecting if nothing is written, like neither with replacement nor without replacement, then that means you are selecting randomly and you are selecting in one time, in one take, okay? Not one by one. So in one take when you select, you just write 22C4, like you are selecting four items out of 24. What it means is that you are selecting four items out of 24, out of 22, right? Okay. It is clear now? Okay. Okay. So next question what we have is that let E1, E2, E3 be three independent events and probability of EI is 1 minus 1 upon 2 by I, and then what is the probability that exactly two of the events occur? Uh, okay, so what is independent event? So for independent event we have probability of B, C is equal to probability of A into B into C. So if we have probable E1, E2, E3, make it intersection, it will be probability of E1, E2 and probability of E3. Now we want to find that probability that exactly two of the event occurred. So exactly two means E1 and E2 occurred, but E3 does not occur. E1 and E3 occurred, but E2 does not occur. E and then E2 and E3 occurred, but E1 does not occur. So the probability we want to find the probability of the event let E be the event such that that exactly two event occur. Okay, so it will be probability of E1, E2, E3 complement plus probability of E1, E2 complement E3 plus probability of E1 complement E2, E3. Okay, so now since these are independent, so it will be just probability of E1 into E2 into probability of E3 complement. So all we need to find is that probability of E1, E2 and E3. So what will be the probability of E1? E1 will be 1 minus 1 upon 2, right? Because I is 1, then the power will be 2 to the power 1. So it will be 1 minus 1 upon 2. Okay. Is my screen visible to all of you? Yeah, but I think there is some issue. Okay, there is some issue. So I'll just tell you. So probability of E1 will be 1 minus 1 upon 2. It will be half. And then probability of E2 will be 1 minus 1 upon 4. I don't know. I think it's hanged already. So it will be 1 minus 1 upon 4. So that will be 1 uh, 3 upon 4, and then probability of E3 will be 7 upon 8. I don't know, I think it's hang, so I will just restart it, okay? Hello? Hello? Yes, so I'm audible to you, right? But I don't know, I think my laptop is not working properly. There is some issue with it. I don't know. Okay. So let's just say that probability of E1 will be 1 by 2. probability of E2 will be 1 upon, 1 minus 1 upon 4. It will be 3 upon 4. And then probability of E3 will be 1 minus 1 upon 8. So it will be 7 upon 8. Right? So now we want to find this probability of E1, E2 and E3 complement. So it will be E1 will be 1 upon 2, it will be 1 upon 4, and this will be 1 upon 8, right? So here it will be 1 upon 2 and E2 complement will be uh, 1 upon 4 and this will be 7 upon 8. In the last it will be 1 upon 2, it will be 3 upon 4, it will be 7 upon 8. So, can you just add it? What is the answer? Okay, 31 by 64. Okay, but I'm unable to do anything here, so how to move in the next part?